Hi, fourth years. Here's your assignment, and it's this week, and it's all about alcohols as fuels. So we're going to be looking at balancing formula equations using the last equation that you need for National 5, E equals C times M times delta T, and just practicing that this week. So quick resume, just go down the slides. There are a couple of videos to watch, but let's just quick resume on how to balance formula equations now. When you do balance of combustion of a hydrocarbon or an alcohol, it's always going to be, I suggest you always do the carbons first, then the hydrogens, and then the oxygens. So I'm going to quickly resume through that as a practice here. So we've got shopping list down here. Carbons, 3 on that side, 1 on that side. Hydrogens all together, 8. 2 on that side, 1, 2, 3 oxygens on that side, and we've got 3 oxygens on that side. So as I suggest, do carbons first. 3 carbons, I need to put a 3 there. I've got 8 hydrogens, so I need to multiply this by 4. So that is now correct. Now that is now balanced, but the oxygens aren't. So I've got 3 times 2 is 6, 4 times 1, so I've got 10 on this side. But I've also got 1 here that I can't do anything about, so I need to get this to 9. So 9 times 1. I need to make that 10. So 4.5, it's going to squeeze it in there, times 2 is 9 plus the 1. So the other thing we're going to be looking at today is this last equation. Now you'll find this on page 3 of your data booklet. The first equation there, and you'll just notice that it's E little script h. Now that is heat capacity, it's heat energy. Now you'll sometimes see that as also delta H. When we talk about enthalpy next year, it's per mole. You do not need to do it per mole this year. It might be a problem solving per gram, but you do not need to work out per mole. So what do these things mean? If you're doing physics, you'll have come across heat capacity of a liquid. Now, we're just going to skim over this because in chemistry, majority of the time, it's always water, apart from the one example Mr. Hay showed in his video. But it's always water, and it's kilojoules per kilogram per Celsius, right? And it's kilograms here that's important because the next thing is the M, which is always the mass of the water. So that's highlighted on both slides and the video. You need to convert that, and it will be in centimeters cubed, and it will be in volume. So you'll need to divide that by 1,000 to get kilograms. Okay. And then the delta T is obvious. It's going to be, if it's a combustion reaction, it's always going to have a higher temperature at the end. So you take your high temperature minus subtract your beginning temperature. You always make that negative because it's an exothermic reaction. But I find sometimes you just leave the negative out till the end. So typical question here. It is, first thing, 3 marks. You do not get a mark for just writing out the formula. Okay, you need to do a wee bit more to get your first mark. C is 4.18. Now that is also in your data booklet, last thing on that contents page. It's not to do with the alcohol, ignore that. It's to do with the water. Divide that by 1,000. And then what's your change in temperature? Well, change in temperature is what you ended up with, what you started with. So if you rewrite that, you don't necessarily need to do this every time, but if you just write that, that will give you your mark, first mark. Then actually do the multiplication, and then what you end up with is, if you do that, let's quickly do that, it's 4.18 times 0.1 times 3.3, and then you end up with your 6.897. It's got to be negative because it's an exothermic reaction. Don't worry about units. So you get a mark for the exothermic and you get a mark for that. Now, guys, rounding up, National 5, 2 decimal points is fine. So you could get away with just 6.9. If it rounds up to that, that's fine. But if it's easily round up to 2 decimal points after that, that's okay. So either one of them would do. But again, show you're working as much as possible. I know that's tricky when we're doing it online. Now, if we've got time here, the last thing is if there's an extended one,